Hey everyone, and welcome to our new Supra video. Today it's gonna be one of the most interesting ones. Right here we have Bartek from HTG.
Hey guys, hi.
He's a guru for the automatic transmission control units.
Yeah.
And today we're gonna change the transmission completely with the Supra to an 8 HP
70.
70. Yeah.
That's the plan. So yeah, 70 is like the stronger version of what's in this car from factory. More power, I mean,
Yeah.
you can go crazy with torque, drifting capabilities, so it's gonna be fun.
And it should be almost bolt-on.
It should be bolt-on.
Yeah.
Yes.
Cool.
Cool.
So let's get the car inside. It's chilly out here in Finland, so let's go. So today we came here to my team member Markus's shop, AMG, which they do a lot of work on automatic transmissions anyway. So
That's a good place to have it done.
yeah,
Yes.
for sure.
Yeah.
So you had some kind of plan to how to do this.
Yeah, so we need to do a couple of things. We need to physically change the transmission, so this one needs to go down and the new one needs to go in.
Okay.
New transmission has to be rewired, so we need to drop the TCM from the transmission, which is the Mechatronics module, and wire the GCU in. We need to physically put the wiring inside of the car and connect it to the chassis somehow.
Okay.
And then
Somehow.
we'll figure it out to make it nicely and make it reversible.
Yeah.
And we have one more thing to do, which is a diff control. We have a new controller to control the lockup.
Yeah,
so you
that's
can do like welded diff without the welding. So we need to also route it somehow, make it hidden in the panels and make it work. So we have quite a lot of things to do.
Yeah. I'm also excited about the diff control because I've noticed that this car, it doesn't work as well. Even at winter, sometimes it's just keeps spinning on the one tire.
Oh yeah, and that's fun fact because the differential can be fully locked or fully unlocked and everything in the middle. So with the standalone control, we can lock it and have it locked all the time. So that should be cool.
That's cool.
That's a new product, so
Yeah.
it's a learning curve.
Exciting. Should we get started?
Sure, let's get it done.
So just disassemble the car first?
Yes, we disassemble the car, we make a good plan for routing the wires, and then we lift the car and physically drop the transmission. It's a couple hours of job to be done, but yeah, the sooner we start, the sooner we get it done.
Let's get to it.
Yep.
No niin, täällä samalla kun kuunnellaan noita autot paukuttelee tuossa rajoitinta vasta ja liekkiä, niin katsellaan vähän kaarvertikaalia. Täällä on muuten aika hienoja autoja. Näistä nyt ei valitettavasti saada, kun ei ole rekkareita eikä muuta tarjolla, niin niitä ei saada, mutta mulla on tässä tämmönen Porsche 911, joka on Jenkeistä tuotu ja aika pahasti kolaroitu keula. Ja no onneksi ei ole moottori keulalla, että se saattaa olla muuten kaikki ihan hyvin. Mutta 2 kertaa kolaroitu ja täältä hyvin, tää hauskasti näkyy, täällä on Lemon title. Tämmöstä en ole ennen nähnyt, eli Jenkeistä. Varmaan tarkoittaa salvaketitle, eli silloin se voi eksporttaa, mutta eikö se aika sitruuna ole, jos se on noin pahasti kolaroitu. Mutta tosiaan 2 kertaa kolaroitu ja muutenhan se on makea Porsche. Yllättäen täältä kun otetaan historiatietoja, niin Suomessa kun on kolaroitu, niin on samalla sitten vaihtanut omistajaa aika monta kertaa ja hylätty katsastuksessa ja mitä lie. Mut hei, käykää kattoo näitä raportteja. Koodilla FDT saatte 20% alennusta. Voitte katsoa teidän oman auton tiedot. Jos sieltä löytyy jotain, jos olette ostamassa autoa, ikinä ei tiedä, kannattaa tsekkaa ennen kuin ostatte autoa. Käyttäkää koodia FDT, saatte vähän alennusta. Kiitoksia. Mennään kattelemaan vähän lisää paukutusta.
Okay, so in here we do have a original differential control which modulates motor in the differential. And we're going to replace this unit, which is a original BMW/Toyota module, with our new product. And this is actually a mock-up, and I have a prototype version in here, and this is a standalone differential control. So it is going to operate it instead of the original one. Here we have 2 connectors from the original loom going underneath the car to the motor to all the sensors. And we've prepared, let's say, those pigtails adapters. So the plan is, instead of cutting and soldering or doing any work with the original wiring, we have the adapters. So hopefully the plugs, this is the first unit, that's a prototype. I think those should be matching, so they should plug right into the connectors and allow us to interface with this prototype in here without any major modification, and later with the final version. So let's see. Hopefully. Okay, so those two connectors are out, and I just hope that I picked the right sockets. And that would be the first one. Yeah, it goes right into it. And the other, yes, works. So that's a good news. We've just picked them up based on the photos, and it works. So right now this is going to interface with the DCU, which is a standalone, which will go in the place of original driver. Now the only thing in here is that there is no CAN bus connection in here, and we need to have the CAN bus connected to our device, so we'll need to route it somewhere. And my plan is to have this wire going to the gear selector, which is in the center console, and it has the PT CAN, which is a powertrain CAN, which we'll be using for the GCU, engine management, and stuff like that. So yeah, now we just need to disassemble the trims a little bit and have this wire go in front. That's it. So this is actually the alpha version. So that's like the first. It works. We've tested it quite many times. But you know, when doing the alpha version, you want to save time as much as possible and get the technical stuff done. So you know, the casing is just so it is. This is like the final design, which is a small, it has a more compact PCB, it has all the connections in there, so effectively it will look like this. But this design has been finished yesterday, last night, 3D printed just quickly, and right now we'll be doing all the final PCB work, soldering and production. Well, unfortunately, during this testing, this project, we'll need to use still the alpha, because that's what we got, and later you'll just swap it for this one. But yeah, it looks good, but that's what works, right? But that's for later. To make it work, only thing left, we need to connect the CAN bus wires into the flex right here into the shifter connector, because that's where the PT CAN is. And the same place will be joined for the GCU to operate the transmission. So we'll be joining all them together in one place. And that's pretty much it. So we're going to take a look at routing the GCU loom, which I have here. So that's a little disassembled loom for the 8 HP. It will go right into the 8 HP, which we need to rework, but that's in a second. And this is the main connector to the GCU. Obviously, once we have all the wires joined, we'll cover this area so it looks nice and heat-shrinked. And those two connectors, one provides voltage, ground, so like the main chassis connection, and the other is for like additional stuff if you want some additional paddles, which you have on the CAN bus, or some clutch-by-wire, for example, goes in here. We'll use this for additional connections. And that's pretty much it.
All right, sounds good.
Then we'll just need to decide where to put the GCU. The loom is long.
Did you have a place already in mind that this...
So LZ never mounted it. It was laying around in this glove area. But there is plenty of space in here, or we can also put it at the back of the glove box.
We take that off so we can see a lot more.
Again, to lead the wires to the place where the GCU is, and we'll join it in one of those connectors. Just so we do not overrush it, we still need to remember that we need to back the car up on the jack. So we'll just temporarily plug this one in a second just to move it back on the hoist, and then we can disassemble it further. But yeah, good stuff.
Työharjoittelija Juha.
In the front? Yeah, let's do to the front. Nice. Good. Now we need to drop the transmission mount.
the weird.
Oh, there's one more thing that we need to measure because I'm not 100% sure, but so the 8 HPs came with a different bores and sizes, offsets of those. So just we need to make sure that it's the same.
18,5, joo. 18,5.
8 HP 51, yes. So it's a 22 millimeter insert size. So that's the same for the Natalie 57. That's the same. Then we have oil cooler ports, 1 millimeter difference. So we may need to kind of bore it in the next transmission, but we'll see. It's just, it may be different by 1 millimeter, so we can bore it, but we'll see.
But it's smaller. So,
so the transmission is smaller.
Yeah, so we can make it just bigger.
And in this case, here you have M8 and your transmission has M6 bolt.
Oh, yeah.
But the transmission that we're getting has a M6 as well, so should be plug and play. We'll make it work somehow.
And the other transmission, it has the turbine.
Okay,
Yeah.
good.
So no problem there.
The worst case scenario, we can put AN fittings in here and weld them. And
Hopefully not.
Probably not. We can also consider mounting GCU somewhere in here.
Okay.
So then we don't need to extend this loom there. We can put it somewhere here. It would be a little more accessible. But let's just see what options we have in terms of...
I'll lower it a bit more so it's easier to see.
So here we have all the original ECU things. So here we have the whole controller.
Okay.
So let's open it up.
It's Christmas.
It's Christmas time. Oh, you do it. You do it. That'll be. Okay.
Oops. We had a controller.
Yeah, exactly.
How many did you bring?
Oh, it's just this one, so it has to work. Right. So that's the controller. Here we have still additional plug and terminals.
Sorry. Yeah.
Yeah. So we need to find a mounting location for it. So my suggestion is we put it in here, then route this wire down the firewall over the transmission,
Okay.
and we'll get all the power wires from here. The only thing that would need to be connected from the inside of the car would be the clutch pedal, and that's it.
All right. Sounds simple enough.
Yeah. So
And even better if you just find a place for it.
yeah, we'll probably mount it somewhere here, and that's it.
Okay.
Okay, let's try.
Should I read the instructions now?
Oh, there is no instruction. The instruction is online. We saved trees.
Okay.
Okay, so we've successfully routed our wiring loom through this compartment down to where transmission is mounted. And in here we do have a branch that used to be the original plug.
Original, yeah.
The original plug. It's cut in a way that we can restore it at any time. And we have just 4 connections, let's say. We have a ground, power, and 2 CAN buses that we'll need to have connected to the GCU.
Right.
And we'll make it happen by attaching to one of those Deutsch connectors. So we'll crimp those wires in a second and attach them to the other side of this plug, so basically to this.
Okay.
And power and the ground will be attached to this small connector, so also here. And in addition, guys installed a clutch pedal wires coming from the cabin, and here we have the loom. We need to attach it to this connector as well, and we'll be good to basically proceed with the transmission part, because we'll need to rewire the transmission and then later install it in the car.
That's basically all the wiring.
That's basically all the wiring. So the important wires is just this loom. If you wouldn't be using a clutch pedal,
Yeah.
that would be just it. So power, ground, 2 CAN buses, done.
All right.
That's simple. And this place looks pretty good spot to have it mounted, because we have a covers coming in here and coming in here, so it should be pretty clean install once reassembled. So let's get it done.
Differential control went inside
Yeah.
and not here.
Yes, but the differential control CAN bus will be attached to the gear lever, which
Alright.
is in there anyways.
Okay.
And the CAN bus is like the common bus
Yeah,
of
so
the
it's the
communication. So regardless if we're connected here, there, or any other place, it's still
Alright.
the same bus,
Alright.
as long as it's PT CAN.
All right.
So yeah.
So this is the pedal it has. It's Bosch. They had few different and diffs
Okay.
fit the best. So maybe this will make more sense to you than me.
Yeah, so we have 6 wires, and here we have labels to wire 1, 2, 3, 4, 5, 6. We'll just need to take a look which pin is which color, because we don't have this specified in here. And so we have 2 potentiometers in the pedal. Sorry for my slack. And they're basically showing pretty much the same thing, probably with the different values. So yeah, here's a diagram showing which one is a ground, which one is a signal, and which one is the voltage supply as a reference. Okay. So in this case, for example, pin number 1 is a reference. Signal for this pair would be pin 6, and the sensor ground would be 5. So 1, 6, 5.
1, 6, 5.
For example, and the other pair would be 2, 3, 4.
All right.
So 2 would be a voltage supply, 3 would be ground, and 4 would be signal. So we just need to check the colors and then connect it in here.
Okay, so we only need 3 wires.
So I need a hand, grab this and the other probe, and just find which of the white wires beeps.
Just try them all.
Yeah, just go one by one.
This corner,
It's just this one, yeah?
nothing else.
Okay, so which pin is it? Yeah, there is a number in here. 1?
It's 7. 7. That is 8. That's
7.
Yeah.
7, 7, 7. This one is done. So we have all the connections done. And that's it when it comes to chassis wiring.
Except the differential.
Except the differential, but that's a little separate story.
All right.
From our perspective right now. So let's just have those plugs hidden in here a little bit, so we can slip the cover on it and see how it looks all in its final shape. Good stuff. Yeah, we can zip tie them later. Right.
Very noticeable.
Yep. So then the GCU,
Yeah.
which is in here, let's just grab it, leave the SPI connector, goes into this. We need to obviously finish this bit of loom, because I wasn't sure if we're going to connect anything into this, so that's a temporarily. It will go somewhere here, we'll make a mount for it, and then this goes on top.
Yeah.
So it's not, so no one knows it's even there.
Exactly.
Good. Right, so now we have the last step, which is doing the transmission. So yeah, let's go and see the trans.
Cool. We had a little mishap with the transmission.
Yeah, so we have that's the original 8HP51, and that's our 70, which is supposed to go into the Supra. And it looks pretty similar, but different at the same time. So,
And this is my mistake. Like I didn't know the difference, and
well, it happens. So what happens here is we have a 6-cylinder bell housing pattern, and we have a V8 bell housing pattern from N63, and that's a B58. So
we are swapping a V8.
yeah, so
In the
that's a one way to go. It's not a bad way. But what we wanted to have a diesel, 3-liter diesel N57 version of the 8 HP, which has exactly same bell housing and is a direct fit. So it won't work. We just need to get a different trans. But to save the time, what we can do, we can pull the Mechatronics from this trans, have it already rewired, so when the new trans arrives, we can just put it directly in, and this original trans stays untouched, so it can go back into vehicle at any time and just be OEM again.
Yeah. So we've called everyone during this day and trying to source another trans. And gladly our friend Samuel had it. It's just far away, but we'll get it in the morning here.
That's good.
So we can swap the trans tomorrow and just do everything ready when it arrives.
Yeah, most likely this torque converter will have to stay on the engine because of the distance, because of the fact that it actually matches the flex plate on the engine. And other than this, we just swap the transmissions, put the new TCM in, new oil in. We have the wiring loom already done, so tomorrow is just coding and driving.
Cool.
So
Sounds simple enough.
Yeah, let's get down to it.
All right. Yeah, I didn't even know that the pan works as
the filter.
As a filter, yeah. That's why we have a brand new one over there.
But that's a good thing, actually. Yeah.
We have all new oil and the filter. Just in case.
Yes.
It's a used trans anyways.
Yeah. Okay, so underneath this oil sump, we do have a valve body and the TCM, which are responsible for controlling the transmission. So it has the solenoids in here, and on the other side there is the actual controller, which we are going to pretty much destroy to put our PCB board in.
All right.
But that's the process that it takes, so yeah. Taking the opportunity, we have the oil pan, which has a filter built in here. So as the transmission sucks in the oil, it gets filtered, and then it gets into the TCM, into the valve body, and then into the rest of the system. And also it has a magnets in here which gather all the shittiness from the transmission, all the shavings. So it's good to replace it if you have the opportunity. Right, so we need to undo the bigger bolts in here to pull the Mechatronics out, as well as the sensor in here, and we'll be able to pull it all out. So yeah,
Was it?
the bigger ones. Yeah, those.
Want to do the honors?
I can do, sure.
You know which one to take off.
Yeah.
Probably done this a few times.
Yes, probably yes. Okay. So that should be all. So now that we have all of them undone, it should be pretty much free, but we have to, we have to release the sleeve, so we need to pull this tab in here, and once we start to move it, we should be able to slide it out, unless we forgot one of those. No, I think they're all done. Okay. Okay. Work its way out. And there we go. So again, this is the part that actually hydraulically controls the transmission. We have set of solenoids controlling the valves inside of the Mechatronics, and all the magic of shifting and operation is done by just operating pressures with those solenoids. We have two sensors, three sensors actually, temperature and two shaft speed sensors. Here is the output shaft speed sensor located just at the exit of the transmission. There is another one in here which is the input shaft of the transmission. We have also park position sensor, analog one, and the temperature in there with the thermistor measuring that temperature. And in here is the original TCM, which we're going to cut out to install our PCB that connects all those sensors, all those solenoids to the HTG GCU standalone. Yeah, okay, so let's start disassembling this. We need to pick the right bolts, remove them, and then we'll be able to remove the TCM part.
So even though this is the wrong transmission, but still this is the same as the one we're getting.
Yeah, so in 8 HP, fortunately, the electronic part is the same, so we can use this version and put it in a different transmission as long as it's controlled by the GCU. because there are some differences in programming when it comes to OEM use, but in our case, we can just take it and put it anywhere else. Okay. Job done. Here is where the brain is, the main controller, and we'll just cut it open and we'll do soldering in there. So my question, do you have like a ultrasonic cleaner or something to put it in a bath, or just
We have
to degrease it?
we have that brake cleaner and
Oh yeah, we can use the brake.
washing machine. It's 90 degrees, so I'm not sure
Maybe too much.
if that can take.
Well, the oil is.
The oil is
Over-
like 140.
Yeah,
So, yeah.
there.
It'll be just way easier without the oil to make it
True, and that will
all
clean
the
it up.
soldering. So now we have TCM that is relatively clean. And what we need to do, we need to access the compartment where the original MCU is, and it's below this plastic part. So the easiest way is to get some cutting tool like Dremel or something and just cut this area out so we have easy access to the metal pan inside. Once we have the plastic out, we'll be cutting the pan open as well. I'll cut open the plastic area and then we'll move to the next point. Okay. More cutting.
Yeah. All right.
Still works.
This looks like a brain cursor.
Not yet,
I'm not a surgeon.
but I can have a look.
Exactly. So now we can see the original TCM cover, and we'll need to precisely cut it on the edge, making sure that we don't make too much of a mess inside, although it's not super critical. But let's open it and then we'll do soldering inside. So, yep, more cutting. This time it's metal. I hate this, by the way. Okay, so we do have a TCM cut open, and what you can see inside is the original circuit board that controls all the functions. It looks a little different to most of the electronics that you can see. Most of the components do not have their casing on. It's a hybrid solution, but regardless of how cool it is, we have to take it out completely. So we're going to destroy all the bondings which connect TCM to the outside pins. And using those small dots in here, those will be the seats for our PCB, which will do all the cross connections between the outputs, sensors, and the connector in here. So we need to remove all the bondings, then we'll need to use the abrasive blade once again to find all the edges and those soldering pads, and then we install the PCB in. Symphony of distraction.
I have to admit, it's kind of hard to watch you destroying all that stuff, but
It is what it is.
sadly I know what you, I think you know what you're doing. So.
I have no clue. I've seen some YouTube
But I
video.
think you have, so
I think, yeah.
that's the main.
That's good. That
That's
keeps
the
you
point.
calm.
Yeah.
You want to get rid of as much of this crap as possible, all those bonds and everything. Well, actually, we can actually use a chisel and a knife and a hammer to get the whole board out. doesn't want to come off easily.
No.
So, long story short, because it took actually a while, we have the original TCM out and we have empty space to put the PCB in. So let's get the whole area clean, let's remove the remainings of the bonds, then degrease it, clean it out, probably grind those edges a little bit so no one gets cut by it, and then we can go to soldering stage. Pretty important part of it is to make sure that none of the leftovers, for example, short one of those pads to the case, because then we would have a wiring short to ground. Those bonds used to be very, very small, so it takes significant attention to go through this, but that's a very important step, so it cannot be rushed in. We need to have everything checked that it's proper, that there are no leftovers, no, things that shouldn't be there before we actually move to the next step. So yeah, let's double, triple check before we move. Okay, let me get the PCB. Originally, we designed a manual describing how to route the wires connecting one pin to the other and the other to the other. So there was quite significant spaghetti inside, but after some time we've released those PCBs that are pretty much an easier solution to do, because instead of doing every wire single, you just solder in this PCB in and it takes care of all the connections. We need to cut out some remaining parts of the metal pan so it can go in freely, and then we can solder it like this, but we'll clear it anyways. So as you can see right now, this board goes very close to all those pads that we need to solder, and we'll just solder jumpers from the pads to the PCB. That's it. So let's clean it more and then we go.
Looks good.
Okay, good. So now it sits in place. So what we need to do is to solder all of it. Yep. But now we need to measure everything, check if there are no shorts.
Yeah.
Okay, desoldering. Good. So always check, double check, triple check.
Yeah.
Because
It's easier now than when it's out there in the oil.
Oh yeah, definitely. But it's just, when you're soldering, especially with these kinds of tools, you have to put a lot of heat, and then there is a risk that you put too much of a tin, so it touches. And it was actually just a very short hair, that touched it, but it was enough to blow this thing, to blow all the fuses, because we had actually direct short between ground and power, so so that was like the worst. Not like some of the sensor would fail and just show some bullshit reading. We would just smoke it away. But yeah, always double check.
And use the right tools.
Yes, regardless if you're pro or amateur like me, then double check. So my suggestion is, because we can actually plug this to the plug that we have on the car, we can lift the car, plug into the GCU, and we can wave manually in front of the sensors to check that the sensors actually work properly.
All right.
And that we have all the continuity to the solenoids. So we can make a valve test. Since we're not in a rush because we don't have the actual transmission, we can just run additional check and then put a silicone on top of it to be safe. So yeah, let's do it.
Sounds good. Sounds like a plan.
Yep. Okay, do you mind switching ignition on?
All right.
So what I want to check is that we have the power connections made good. So I'll just measure that we have voltage where we should have and that nothing's, wrong. So right now, yeah, we have 12 volts on one voltage pin, 12 volts on the other, 12 volts, M3, 12 volts, L1, which is the ignition switch, 12 volts. So good. Okay. Yes. Yep. And this we have to connect in here. Okay.
Oh yeah, now we can connect that underneath.
Yeah, but first I will flash the GCU with the program that is going to check our solenoids. So I just need to, it's a brand new device, it has nothing in it, so we just need to put the base program in.
All right.
So right now it connects through the internet to our server and it gets the latest software for it. Takes around a minute, and then we connect it to the car and just get it done.
That was pretty easy, just plug and play and...
Yeah. Okay, so right now we have a readings of sensors, so we can test a speed sensor. So we have one of the speed sensors in here, if you hold it for me. So we have a speed sensor in here and we have speed sensor in here. Okay, so the procedure that we have on the display right now is what we call a valve test. And what it does, it tests those valves in the Mechatronics on the TCM if we have them connected. So we can count the amount of them. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's exactly the amount that we use in the 8HP. We have no feedback. There is an article describing how this test should result, and it's a perfect example of how it should. So we have solenoids working. We have a temperature sensor working. We just need to double check if we have a speed sensor working. Maybe the magnet wasn't just making it picked up, and then we'll be good to call it a day. Yeah, try to kind of like rotate. Yeah, okay, it picked up, nice. And the other.
Huh?
Can we try this one once again? I think we're just too slow. Yeah. Should we bring the transmission just to be triple sure?
Yeah,
We can slide it in the transmission without like bolting it, just so it lays there, and that's it. So let's make it like this.
Yeah.
Okay, we read this. Okay, we have a clear reading here, and now it's just take a look if the blue line appears on the first graph, on the top graph. Something draws right now? Nothing, nothing? Okay, you don't need to hold the park for this. It would draw it anyways. Okay, so we need to take it out and we need to check why we have one signal missing. Debugging. Let's go to pin 10, which is, let's put it once again in the transmission, because there is nothing wrong in the wiring. It's a blue color, right?
Yeah.
Yeah. So
Yes. Yeah.
Okay, good.
So just too slow.
We're just too slow. That doesn't sound good in a tuning video, but okay. Anyways,
Should we try that?
so we're ready for tomorrow.
So now we have the correct transmission here.